try problems, your goal is to solve the following compound inequalities graphically, and still we have the three-part inequality, inequality connected by and inequalities connected by or all together in now you try type of problems, and your goal is still to graph without technology with proper scale and labels and find the intersections on the graph that are relevant in order for us to find the solution and eventually write the solution in interval and set notation. So take some time to work on these problems on your own by referring to the examples we went over in the lecture videos, and once you are ready to go over your solution, you can continue the video over here. In part 8, we have an inequality with a lot of fractions involved. And with this type of inequality, if we want to graph it by just using the proper scale and things like that, there are some tricks we can do in this case. So for example, if we have the denominator in here being 6, 2, and 3, we know that we can find the least common denominator first. And the least common denominator will be 6 in this case. So that could be the lowest or the smallest unit that we can use over here. With the 6 being denominator, we can go by 1/6 every time we go up or down the units over here for the y value especially, because we can see we have the y value being bounded by negative 7/6 and bounded by 1/3. They can all be scaled to be multiples of 1/6 over here. So we can make our scale equal to 1/6, at least for the y coordinate to start with. And with this information, we can get 2/6 is equal to 1/3, and then similarly we can find where negative 7/6 is by counting down 7 slots over here. So that would be negative 1/3, negative 3/6, 4/6, 6/6, which would be negative 1, and negative 7/6 right over here. So that's how we can use the scale for y-axis to easily graph things nicely over here. And we can see that every time we have the negative 2/3, which will come up as the y coordinate for y-intercept over here, that would be helpful for us to label it right away as well. So we have negative 2/3. Maybe I counted right. Incorrectly. That would be negative 7/6 down here. And this is negative 2/3 over here. So these are some of the key points we can get just by looking at what we have over here. And for the x-coordinates, you have, or x-axis, you have a little bit more flexibility in terms of how you want to scale this. Over here, you can use the same scale if you want and just go by 1/6 every time. You can also just go by 1 if you want to make it easier to label. It's really up to you on the x direction, a lot more than you have on the y direction in terms of flexibility. And I think just by scaling y-axis this way, it makes it a lot easier to work with later on when we're trying to put all the graphs together. And in this case, we are starting with 0, negative 2/3 being our y-intercept. So 0, negative 2/3 is right over here. And we have the slope being 1/2. That means every time I want to go up 1, I want to go over 2 to the right over here. So with the same scale on x and y axes, it makes it easier to find the points later on over here. And then again, if I want to go up by 1, I go over by 2. Over here, I would have another point. And once you have enough points, you can go ahead and connect the points over here. this y equals 1 x minus 2/3 in this. And here we know the linear expression is bounded by -7/6 and also bounded by 1/3. So here we can indicate the boundary by graphing where y equals -7/6 is over here. And -7/6 was not included over here, so we can use a dotted line. Now for positive 1/3, this is included, so we can use a solid line as what we did before. So once we do this, we can find the intersections over here. The intersection for the dotted line is right over here, so we get the x-coordinate is -1, the y-coordinate is -7/6, because that's our restriction. Now on the positive part, the other restriction we get is the x-coordinate over here, so we might need to count a little bit. We have actually exactly 2 as the x-coordinate and 1/3 being the y-coordinate. So when we have the boundary on either end, that means we're looking at the part of the line segment that's between these two values. And again, since we're solving for the inequality, we only focus on the x values. So we can get it's between -1 and +2. At -1, it's not included, so we can see for the interval notation for the solution, we get -1 to +2, and for the set notation, we can say it's x such that -1 is less than x, less than or equal to 2. And I meant to include the 2 in interval notation. And that's how we can go through this for the solution part. If you think you're good with the 3-part inequality, you can move on to part B over here. And with this set of problem, we see that in part B, we have a problem that's connected by the word and. The numbers I have involved, I'm going to go ahead and use the scale of 1 on both x and y axes over here. Again, depending on the area and space you have, you might have a different scale, but make sure it's a scale that's easy to work with and you can consistently use and to include all the key values that we want to include in the process. And here we're going to again let y1 be equal to 3x minus 6 and y2 be equal to -2/5x plus 6. Here we can see for y1 the slope is 3/1 and the scale for the y-intercept is 0, -6. So to get us started, I'm going to label things on the axes first. So in this case, we would get the 0, -6 is our starting point. So 0, -6 right here. And in this case, our slope is 3/1, so that means every time I go up 3, I should go over 1. And we can consistently do this until we have enough points. And I'm going to go ahead and connect them. And as you get more and more fluent on this process, you can catch the boundary values or the restrictions much quicker. You might have already seen that -6 is exactly where we started with, so that'll naturally give us a restriction. But if not, we can always use the same method, that this is y1 and we want to find where it intersects with y equals the other side of the inequality, which is y equals -6. So -6 is right over here. We use a solid line because it's included. And with that intersection, we can see that's exactly where the y-intercept was. 0, -6. Again, to solve it, that means I only need the x-coordinate being part of the solution. If I want the graph to stay below -6, that means I'm looking at this part of the inequality over here, or this part of the line over here. So to write out the solution for the first inequality, we would get x is to the left of 0, or x is less than or equal to 0. You can see this will be consistent with what we get if we were to solve symbolically over here. Now on to the linear graph of y2. Here we have the slope being -2/5 and the y-intercept being 0, +2. Sorry, +6 over here. So +6 is actually right over here. We didn't label 6, but we know with a consistent scale, that's where it'll be. And the slope is -2/5, meaning every time I go down by 2, I should go over by 5. So go down by 2, go over by 5 would lead me here. Go down by 2 and go over by 5. 1, 2, 3, 4, 5 would lead me here in this case. And you could keep going if you want. Here I think they're fairly nicely spaced out, so I'm just going to go ahead and connect them. And I want to have the restriction of 5. I know this already crossed the 5 over here, so we get 5 over here. And this is my y2 graph. And if we have the restriction being 5, I want to use a dotted line because that's not part of the restriction, or that's not included as part of the restriction. Here, if we look for where this intersects with y equals +5, we get this intersection right over here, which we need to count a little bit. So that's 6. That gives us this is 7, 5 over here. And with this value, this is the intersection we get. And to find the part that's less than 5, that means I'm looking for the part of line that's below 5. So I'm looking at the highlighted part. If I want to write the solution for x, it needs to be staying to the right of 7. So x is greater than 7, meaning I'm looking for the part where the two would actually intersect with each other because I have inequalities connected by end. With this information, again, you can see the two highlighted part don't overlap with each other at all. With this information, we can say that there is no solution over here. And in this case, we can see this end leads to no solution, but you can see if we had different restrictions, we might have results where we can get the two highlighted areas to intersect with each other and have some sort of solution. But here, to have that end condition, it's a harder condition to satisfy because both need to be included. Both restrictions need to be true over here. Or we can say the solution set is the empty set. So circle with a cross over here. And that's how we can find the solution for compound inequalities, essentially with and being the connecting word.